Continuing with MA 104 Section 3.6, we are asked to do several things with these problems. We have to graph the function, verify that it's one-to-one, which basically means we're verifying that the inverse is also a function. Find that inverse, graph the inverse in the line y equals x, which we already did, and find the domain and the range of the function and the domain and the range of the inverse. So a lot of different things that we have to do, not necessarily in that order. So let's start by graphing the function f of x. This is just a linear function. It's in slope-intercept form. This is like y equals 3x plus 0. So my y-intercept is 0. From there, I will go up 3 and over 1. I could also go down 3 and to the left 1. But in any event, my function f looks basically like this. The domain and the range of that function are both going to be all real numbers. You can get the domain and the range by looking at the graph. You could also get the domain by looking at the equation itself, but the domain is all real numbers, and the range of the function f is also all real numbers. And I'm using the symbol for all real numbers there, the capital R with the extra vertical bar. To find, actually, before we even find the inverse, we can find the domain and the range of the inverse. We know that the domain of the inverse is just the range of the original function. So the domain of the inverse is also going to be all real numbers. Same thing with the range of the inverse. The range of the inverse is just the domain of the original, so it will also be all real numbers. If I find, or if I calculate the inverse of this function, I know that my function is y equals 3x. The inverse is found by switching the x and the y, switching the domain and the range. So that will give me x equals 3y. To solve for y, I would just divide both sides by 3. My 3's cancel, so I have y equals x over 3, or 1/3 x, which in functional notation, and I use the superscript of -1 to indicate the inverse function. The inverse function is f of x equals 1/3 x. If I want to graph that on the same coordinate system, then my y-intercept is still 0. This time my slope is positive 1 over 3. My rise over run is 1 over 3, or I could go down 1 into the left 3. Connect those points. There's my inverse function, which you can see does exhibit that property of symmetry with respect to the line y equals x. For f of x equals 4x minus 3, again, this is just a function, a linear function in slope-intercept form. My y-intercept is -3, so I'll start by finding -3 on the y-axis. My slope is positive 4 over 1, so from this point I'll go up 4 and over 1. I can do that one more time. Up 4 and over 1. Connect those to get my graph of the function f. Again, you could look at the graph or the equation to see that the domain of the function f is all real numbers. The range of the function f is also all real numbers. Switching those for the domain and the range of the inverse, the domain of the inverse is simply the range of the original, so that will be all real numbers. And the range of the inverse is simply the domain of the original, which is also all real numbers. And again, I could get the domain and range of this function by either looking at the equation or also looking at the graph. To calculate the inverse, my original function is y equals 4x minus 3. So the inverse will just be found by switching the x and the y, which is x equals 4y minus 3. To solve for y so that it's in functional notation, I can add that 3 to both sides to get x plus 3 equals 4y. Divide everything by 4. My 4's cancel. So I have y equals 1/4 x plus 3/4, which when written in functional notation is the inverse function is 1/4 x plus 3/4. So again, it's a linear function. The y-intercept is 3/4, which is approximately right here. My slope is 1/4, so I will go up 1 over 4. Put me approximately here. I could also go down 1 and to the left 4, which puts me about here. Connect. And here is my inverse function, which again you can see exhibits the property of symmetry with respect to that line y equals x. The function f of x equals the square root of x plus 3, I can rely on one of my parent functions to sketch that graph. The plus 3 indicates a vertical shift 3 units up. So if I start at the origin, which is where those parent functions started, and I go 3 units up, puts me right here, and then an approximate sketch of my function looks like this. By looking at the graph and by looking at the equation, you can see that the domain of this function f starts at this point, the domain value or the x value of this point is 0, and goes all the way to positive infinity. So my domain is 0 to infinity. The range of this function, if I come up, this is the first point that I hit, the range value is 3, and then it continues to go upward, so the range value is 3 to infinity. Without any calculations, I can very quickly get the domain and range of the inverse. The domain of the inverse is simply the range of the original, so that will be 3 to infinity. And the range of the inverse is the domain of the original, which will be 0 to infinity. To do these calculations, my original function is y equals the square root of x plus 3, which means the inverse is found by switching x and y. So I get x equals the square root of y plus 3. To solve for y, I can subtract 3 from both sides, which leaves me with x minus 3 equals the square root of y. I can then square both sides, which leaves me with x minus 3 quantity squared equals y. For functional notation, I can say the inverse function f is equal to the quantity x minus 3 squared. This is a quadratic function and its graph is going to be a parabola, but please remember that for the inverse, I found the domain and the range of the inverse. For the inverse, I'm only interested in the domain values that start at positive 3. I'm only interested in those x values that start at positive 3. If I look at my inverse function, the parent function is the quadratic, and I have a horizontal shift of 3 units to the right. So I would start 3 units to the right of that origin. And again, the domain specifies that I'm only interested in the values of x that are larger than 3. So really that only means half a parabola, which ends up looking something like this. So this is the sketch of my inverse function. It does exhibit that symmetry with respect to the line y equals x. In this particular function, I'm already given the domain. I'm told that x has to stay greater than or equal to 0. My parent function is the quadratic function shifted 5 units vertically. So if I sketch this, I would start the vertex with the origin, but then I would move up 1, 2, 3, 4, 5 units. So my new vertex will be right here. Now again, this function restricts the values of the domain to be greater than or equal to 0, mainly so that the function remains 1 to 1. And we know that the inverse is also going to be a function. So here's the sketch of my function f. We're told again that the domain of f is everything from 0 to infinity, which we could also get by looking at that graph. The range of f, if I start coming upward, this is the first point that I hit. The range value there is 5. Oops. Let's keep that in the green. So my range will be everything from 5 to infinity. Very quickly then, I know that the domain of the inverse is the same as the range of the original, so that will be 5 to infinity. And the range of the inverse is the same as the domain of the original, which is 0 to infinity. Calculating the inverse, my original function was y equals x squared plus 5. So the inverse will be what I get when I switch to get x equals y squared plus 5. To solve for y, I can subtract that 5 from both sides and get x minus 5 equals y squared. I can take the square root. I don't need the plus or minus. The square root of y squared is just y, because I already have the restrictions with the domain and the range. I'm told that the domain of the original is everything from 5 to infinity, and I'm also told that the range of the original is every positive number, so I only need those positive values of the radical. So I'm okay with just leaving this as the inverse of f is equal to the square root of x minus 5. If I sketch that, my parent function is the square root function shifted horizontally 5 units to the right. So that puts me right here. And then I have that shape of the parent function, which also exhibits that symmetry. Finally, again, for this function, I'm also given the domain right away, that the domain is to be everything greater than or equal to 1. This is to make sure that I have a one-to-one function whose inverse is also going to be a function. So my quadratic has several shifts happening. I have the horizontal shift. The minus 1 means a horizontal shift 1 unit to the right. And the plus 2 means a vertical shift 2 units up. So if I do that, that tells me that my new vertex is at the point 1, 2. And also that I'm only interested in x values that are greater than or equal to 1. So here's my function f. Looking at the domain and range, the domain, again, we're already given, is everything greater than or equal to 1. So the domain of f is everything from 1 to infinity. The range of f, if I were to come up, this is the first point that I hit. The range value is 2. So the range value is everything from 2 to infinity. The domain and the range of the inverse I can get by knowing that the domain of the inverse is the same as the range of the original, so that will go from 2 to infinity. And the range of the inverse is the same as the domain of the original. That will be everything from 1 to infinity. The calculations then, I know my original function is y equals the quantity x minus 1 squared plus 2. So the inverse will be x equals the quantity y minus 1 squared plus 2. To solve for y, I can subtract the 2 from both sides, which gives me x minus 2 equals the quantity y minus 1 squared. I can take the square root of both sides, so I'll have the square root of x minus 2 equals y minus 1. Add that 1 to both sides, and I am left with y equals the square root of x minus 2 plus 1, which in functional notation just means the inverse of f equals the square root of x minus 2 plus 1. If I plot that, my parent function is the square root function. I have a shift horizontally 2 units to the right, vertically 1 unit up. So I can start right here, follow the shape of the square root function, and also the idea of symmetry is still applicable to get a sketch of the inverse of f.